Alright guys, so we're going to start going over the Arduino code that is going to go on the sun sensor configuration. This code itself is not that complex. It's kind of long, there's a lot of repetition, so we'll go over all of it step by step. We're going to start by using hashtag include, just starting off software serial. Then we need to initialize a bunch of variables of type double, and we need one variable per sensor that we're using. Now we're using 24 photoresistors, so we're going to create 24 variables. There's easier ways to do this than just repeating these initializations. You could make a loop that just concatenates a new number onto the end of sensor value and then initializes it. We just did it this way to show you the most basic way of doing it. It's a little bit long, but it works. Once those variables have been initialized, we need to start serial.begin. As you can see down here, we're printing to the serial monitor, so we need to start that communication at the very top. This void setup loop is only going to run once, so once we begin that at our baud rate of 9600, we also need to start pin modes. As you can see, this is an example of how you can do that inside of a loop. So we're starting pins 4 through 13 on the Arduino, and we're setting them as output. So again, this loop only runs once. Once we're done with that, we go down to our main loop, and this is the one that runs over and over and over again. So as we discussed before, our sensor configuration consists of one Arduino, 3 muxes, and 24 photoresistors. So in our code, we attack this one mux at a time. So this chunk is for mux 1, and then we have a similar chunk for mux 2 and mux 3 respectively. So you can see in my comments here, mux 1 for our sensor configuration controls sensors 5 through 12. Mux number 1 is connected to digital pins 7, 8, and 9 on the Arduino, and it's connected to analog pin number 3. To break this down further, within the mux 1 section, you can see that there are sections of 5 lines of code for each photoresistor. The reason is because we need to be able to tell the mux which photoresistor we want to pay attention to at one time. To start out, this is for sensor number 5. So we need to write to the Arduino a set of 3 numbers, and this is going to be in binary. You can see here digital 9 corresponds to S2, digital 8 corresponds to S1, and digital 7 corresponds to S0 on the mux. The way that the mux works is that you send it basically a binary number, and that corresponds to which Y pin on the mux you want it to listen to. And sensor number 5 in this case corresponds to Y pin number 0. When we want the value for sensor number 5, we want it to listen to Y pin number 0. So in order to do that, we need to send the number 0 in binary to the mux. When it listens for that binary number, it's going to start with number 2, and it's going to go from 2 to 1 to 0. So we need to send 0 in binary to those pins. So we're going to start with number 9 because that corresponds to S2 and send 0, 0, 0, which is 0 in binary. So once we've written those numbers to those pins, we can use the function analog read, and it's to analog number 3 because that's the analog pin that mux number 1 is connected to. And then once we have that value, that'll be in the range of 0 to 1023. We can convert that to an equivalent scale in volts from 0 to 5 by multiplying that number times 5 and then dividing by 1023. So that's basically the chunk of code for one photoresistor. And as we go down, you can see that that's pretty repetitive. There are a few things it changes. You can see here in the next chunk that we're now reading sensor value 6, so that's a different sensor. We're using the same analog pin because we're still using the same mux. We're still using the same digital pins because that mux is attached to the same digital pins, But now we're sending a different command to it. Instead of sending 000, we're sending 001. And that corresponds to Y pin number 1. And 1 in binary is 001. That pattern is going to repeat down for the entire mux number 1. As we get to mux number 2, it follows the same pattern. We're now using different digital pins. So keep in mind to keep them in the order that the S's go in. So we're going to start with S2, which is digital 6, then go to S1, which is digital 5, and then S0, which is digital 4. And again, we're saying, hey, we want you to listen to Y0, and then Y1, Y2, etc., so on and so forth. Now we are listening to analog pin number 2. If you go down to mux number 1, we're listening to analog pin number 1. So you can see this process is relatively simple, but it's very repetitive. So it's going to be a lot of copy and pasting on your part. Once you follow that pattern for all of your muxes, all the digital pins that you're using, all of the photoresistors that we're using, finally we can take those values and print them to the serial port. As you can see, we're doing this pretty repetitively. Again, there are much easier ways to do this, such as putting it in a loop and just concatenating that number onto the end of the string sensor value. And at the very end, we're going to add a delay. That's just to, we'll talk about the delay further when we talk about the Arduino to Matlab communication. But all of these sensor values are going to be added on one line, and then at the last one, you're going to print with a new line. So every new line of data that gets printed to Matlab will contain information at a new moment in time. All right, so let's go to the Matlab code.